So I left the system up and running overnight. It's just running against this FF opcode. FF turns out to be, I believe, reset 8, which I believe jumps to address 38 hex. So let's go ahead and stop the machine. And we are at address 30. Maybe it jumps to address, oh yeah, that's 38 hex or 70. So then if we single step, it jumps off to some crazy address. I don't know what that is. And then comes back down to, so it's interpreting the FF here as reset 8. So that says to me the CPU was actually seeing instructions and running them. So with that said, let's see if we can get this memory card out here. This is the card that was strapped at C000 to FFFF hex. Because I found the proper card that I want to put in here. So I found another memory merchant RAM card. I've got 4 of these, and this is the one strapped in the lower 16K of memory. So this is really the one we want to play with here on the machine. Getting that in the socket blind is going to be rather interesting. Okay, it's down in, and that should get us RAM in the lower 16K address space, which will make things a little bit easier here to play with. So let's do a reset. We've got what looks to be a little bit of random garbage in memory. We're seeing just a few bytes there. Now if I find the next thing I set down, so let me think here. I want to do so the first thing I'm going to do is input a jump instruction, which should, so jump instruction. Actually, let's get all these zeros. Do a reset, and we're looking at address 0. The jump instruction should be 1, 1, and I want to deposit that. And I'm going to jump to address, I always forget the byte order here. Deposit. And then I want to jump to address, which is the address we jumped to, and do an examine to get to that address. And I want to put in another jump instruction, which should be that. I want to deposit that, and I want that to jump to address, oh, doing this wrong. We're still at address that. I want to put in the jump instruction, deposit. I may have got this wrong, and then I want to do a deposit next, deposit next. Let's go ahead and look at address 0, which is where we should have had the jump instruction. I want to deposit that there. I want to jump to deposit next. Deposit next. Reset. We've got the jump instruction to 3770. And if we go to 377, examine, we've got another jump instruction, examine next 00. So this should do a jump up to another jump instruction and back between those sets of addresses. So let's see if this will actually run. So let's get back to address 0 and let's run the code. And it looks like it's trying to do it, so let's go ahead and stop and reset and let's single step. So there's our jump instruction. It's going to go to address where all these bits are ones, all these bits are zeros. We're to that address. It's finding another jump instruction, and it's going to go to where all these bits are zeros and all these bits are zeros. And we're back there. So jump up, and it gets there, it jumps back. So this is just looping between those jump instructions, and that's working. And this is kind of confirmation to me the CPU is actually running. So if we reset again, we're seeing a jump unconditional to address where the lower byte will be all ones here in these, where the upper byte will be all zeros in these LEDs. We've jumped to that address. We find another jump instruction where the lower byte will be all zeros and the upper byte will be all zeros, and that gets us back down to address 0 where we find the first jump instruction, and we just loop here. So this to me really is confirmation the processor card is working. We're addressing memory properly. So that's really good to see. That's really, really good to see. Really happy with that. So really the next thing here is going to be to figure out getting some serial I/O on here. If I had a serial card, we could attempt maybe to run something. I believe this reproduction front panel has the ability to inject code into memory space for execution, and I think there's some, maybe a version of BASIC or something in there. I'll have to look further. So the real question becomes getting a Altair 8800 compatible SIO device. I don't have one. I've got a lot of serial devices. I don't know if any of them can be strapped to be the same. I've got research to do. But oh look, we're drawing enough current here. The 8-volt power supply just spun up. Cooling fan just came on. I don't know what the current draw here is. I don't have a clamp on ammeter to look. But that's pretty cool. That's pretty cool to see the machine at this state operational. Something I wanted to check on. I'm seeing the wait light comes on when I've stopped, goes off when I run. That's correct. We're seeing with this running memory reads occurring, the M1 cycle of the machine's happening, and I forget what WO is. I should know, and I do not remember. But you know, looking good. We can see these LEDs down here are dim because they're only on part of the time as it's going back to address 0 and then up to that address. Initially 377 and then 777 and then back to zeros. So, and we've got address 0, 1, and 2 being red. Why those are a little bit brighter, and then up to the 777, and then actually it would be 377, and then it's going to read address 11 for a jump address, and 12. Again, why these are kind of brighter, again because they're getting exercised more. So yeah, this makes sense. This is pretty cool. Very pleased. Well, this is just a quick little demo to say that we've gotten this far. CPU card looks good. The RAM card is working. It was working when I pulled it out of the other machine ages ago, so I fully expect it to work. The front panel interface card seems to be working, and the front panel seems to be working, so I'm pretty pleased. This is definitely moving forward in a nice direction. So I'll wrap this quick demo up, and we'll talk soon.